stream. Input 0 window starting from 0, 1, 2, 3, 4. You gave 2 inputs. Window 1, window 0, window 1. Then stream 0, stream 1, 4. So that's the reason you have 3 buffers here. Okay. If you had given only window, 2 buffers would have come. Then input mygraph.io. Okay, this is the input that is also getting passed through the some memory, that is buffer. And then finally, these are the inputs. See, win, WIN, if you can observe. Okay, went into input 3, then input out,
it is wala.
in out 0, in out 1,
It is
and then LUT. Okay,
Mila
then
aisa.
finally output data. So input getting streamed directly as output. This is stream. Stream. If you give, this is window based, okay, and stream based. Both you have
10
selected.
बजे आया था 10
Both
10
are
पे.
getting identified. Now here only you have subgraph view. This is subgraph view. You can have tile view also here. You can have tile view also here. So if I get into tile view, no, see here you will come to know which tile has been used. Yeah, you have selected only one AI engine tile. In that one AI engine tile, uh, this is tile first column, okay, and this is tile 1, 3. This is tile 2, 3. Now, why that 3 is coming always? 0, 2, 0, 2, horizontal. And one more thing I wanted to tell you is when you do memory data transfer between memories, no, always it will be horizontal way. Never it will have horizontal transaction will happen always. No vertical transaction will happen between the memory. So master and slave, horizontal way only. Okay. Master and slave, horizontal only. So that is another one thing. Now here, this is our node. This node has one buffer. This is which tile 3, 0. Because I didn't specify which tile it has to sit in and all those things. No? So by default, 0th location. Like if I don't mention where the data has to sit in register, it will default select the first memory location, 0x000. Very much similar to that. Okay. So this is how you can observe. This is tile view. Now the same thing, if you want to use see flat view, this is a flat view. Okay, no differentiation of row, column, nothing. You can only get a information how many nodes I have, how many functions I have used, what is the input, what is the output. If you want to have this, so this is a view, another view you can get. Other than that, you want a array, tile array. Okay, complete tile array for the device that you have selected. This is a complete tile array for the device you have selected. You can expand this. Okay. You can expand this. So this is how the definition of every tile is given here. Okay. Okay. You can just select here. You will get to know all these are runtime parameters. Okay. That is getting updated. Data type, int constant, buffer 3. This is stream based data. This is memory bank, which memory bank is consumed. Okay. So all these information, we can get data sets will be there. There also you can see which bank, if you are finding it difficult to read here. This is which tile. Okay, it is there. Which memory bank and which memory bank are used and which tile is used here. So that information can be seen here. Then you have constraint. You have not selected any constraining here. So that will mapping analysis. Finally, this will be the mapping analysis that you have got. So this is PLIO. Function name is PLIO. Okay. Input output. And this is a node name that you have selected. Variable names will be given and graph name that you have selected. Okay. Then DMA analysis, DMA report. If you have used the DMA, okay, then DMA instead of CPU, you can use DMA as a master. Okay. Then lock allocation. Lock allocation means memory, which memory bank you are using, okay, for interconnecting, which memory bank it is used for interconnect. That featureization is given here, okay. And then finally, AI engine compilation. AI engine compilation will have the CPP include directories that is used, and the name of the project, project type, and CPP definitions all will be given. You can get into the log also like this. Okay, entire information will be got into an analysis. Okay. Now, you have these are all reports. These reports, not mandatorily, I have to check as a part of Vitis Analyzer. You can also check in the code only. Here also you will get the reports. So if I expand this, these are the input factors. Okay. So you can just go on checking here also. You can check here also. Okay. PLIO. So all these observations can be made here also. Okay. Then other things are also available. Reports also will be available here. Finally, AI simulator output. Okay. In that you have a data summary. Okay. Summary you can get here. Again, the same thing is open. You can just. So these are the various options that you have when it comes to AI engine tiles. Okay. Now further, you can also check with the run summary report. This will be a run summary report. In the run summary report also you have a graphical view, okay, and then array view and log, okay, in the run summary report. Not only that, you can also check, you can also expand this, the one that you have run on x86 functionality test, that also can be done. So here also you have a compilation summary. Again, a Vitis Analyzer will open. You can check here also. This is with respect to x86 processor. So you can open the binary container here also. Here also you'll have a kernel guidance, graph and log report. So check with the kernel guidance. That various things are not there. Flat view, other things, reports that we saw, no, that will not be available as a part of this. Only a view, graphical view is available as a part of this. Okay. This is about your Vitis Analyzer part. So overall conclusion is we have seen the AI engine tool flow, where what exists and how to test the and simulate using AI engine. Okay. So we have run as a AI engine
computational optimization is happening here. Whether any analysis we can do, what are all the resources used?
Actually, you can.
Tell me, ma'am.
Actually, this we have not selected any optimization here, correct? So if you can, as it is, check with this. Further, if you want to have optimization, then you can select this, right click. As I showed you, get into this, perform the optimization technique. Optimization are two types. One is tool based. Another one is you write code. Okay. Code level optimization is also possible. ID level optimization is also possible. This is a tool-based optimization that I'm doing. Code level optimization is also possible. So change here the settings. Okay, this is basic optimization. I set it for basic optimization, heap size, based on the heap size. So you can say no optimization also. Then apply and close, rerun the thing. So you can perform the timing summary analyze, check with the summary and perform with the timing report you can get. That way you can do. This is with respect to tool I am telling. With respect to code, different optimization technique will be there. Okay, code level optimization is different. This level optimization is different. Clear with this? Okay, this was a basic design tool flow that I have shown you right now. Continue, ma'am. Any other queries?
Ma'am, can you just show me that timing summary of this?
Yeah. Now I have to rerun again if you change the I've changed it to default optimization. So I have to build and rerun again. Instead, the one that we have already generated, that I can show you, because build will take time. Here, you have summary right here. Compilation time. Okay, we can check it here only. On the console also. So the AI engine frequency is this one. Elapsed time is 12 seconds, correct? No? This is too light, I feel, for you people also. This is 1250 megahertz. Huh? So you should get into default and get into summary. Okay.
Okay.
So with this, with the help of this, I can estimate the time also. Provided you should very apt, you need to know the input frequency also for this works with 1.7 gigahertz. No? I'm not sure. Okay, check once. Okay.
Yeah. Okay, ma'am.
Yeah. Thank you. So this is just an overview of the tool flow. So I'll just repeat once again. Input will be kernel code .cpp. In between, you will have a compiler simulator. Compiler, which will give you, with the help of V++. Okay, like GCC, you have V++ also. With the help of that, you will get L file. Then simulator will help you to simulate and analyze the result. So these are the things that has to be obvious. There are other things also here. Those who are interested, binary container, you can perform the binary container settings, and you can do all these stuffs. Emulation software, you can check with the run summary and other things also. Okay, this is how. So another thing is, if I select this golden output data, you have to simply, I can't compare. This will not be enabled at all, always. If you select this, select the other one also with the help of control. So I will select this also, then only this will be enabled. Each other after transformation. Till that time, it will not be enabled. It will be in a disabled mode only. So you need to have two factors to be compared. Otherwise, it will not be enabled at all. Okay, clear with this? Okay. Now, we'll continue. So you have to go through certain functionalities, choose which style you want, and then you can make a selection as per that. So we are not getting into too much detail of that. Okay. Now, when I talk about a vector register file, no, there are two ways you can define. Okay, I will just show it on. So there are two ways. Okay. So AI engine vector unit will support integers 8, int 8, int 16, int 32-bit, along with real and complex numbers. Now you can perform MAC operations. Okay, multiply and accumulate operation. So the vector data type, if you want to give, no, it will be something like this: AIE, okay, colon. That is not caps. Okay, it has to be in a small only. Colon, vector. This is one of the intrinsic function I am showing. That's all. Less than bracket C. That means how it handles the data type. Okay, U int this is the way you declare, and these are called as intrinsic functions. Size of element. Okay, and number of lanes. This will be always having num lanes. Why num lanes means num lanes. Okay, so you can have vector type, or you can have static the scalar type. So AIE, you can have accumulator. Anywhere you can choose accumulator or some other variable name also you can give. Same way. Okay, accumulator float. So that way also you can give. So something like you will have V4, okay, int 32 or float 32. Okay, your compiler will see this as V4 int 32. Means the data type is integer that I am using. It is 32-bit data type. 4 is lanes. That 32-bit data type will be divided into 4 lanes. 4 lanes means 32 divided by 444. Okay, 4 lanes it will be divided. That's how SIMD operation will happen. Okay, scalar also same. It can be float or int or any data type, whichever it supports. So you will have 8 lanes you will have. No, now 432 means 8 lanes you will have. So if I give some 32-bit data, it will be affixed something like this. So say I will give only 5 because that's easy for me to type. So 5. Like this 4. Finally, this will follow little endian style only. The storing of the data, whether it is in memory or in a register, it will be little endian. Little endian means lower byte, lower address, higher byte, higher address. Okay. So little endian style of storing the data only will happen. Okay. Like this, it will be stored. 8 lines you assume. Okay. This is how the data will be stored. Again, second set of data, input 1, input 2, no, because 2 operation has to be performed. Or simple, this data only you want to do some comparison and feed it out. Then also okay. If the same data you want, next data also should have same number of lanes for comparing or for performing addition, any operation you want to perform, it should have same lanes only. And even the size of this should match. Otherwise, like C program only, you will get fatal error. Size mismatch will happen. Okay. Same functionalities will be followed here also. So I want to add with this number. followed by all 0, 0, 0, 0. Okay. So this number is 5. This number will be, last number will be hex format only. It is 1 followed by whatever number, 0, 0, 0, 0. Okay. This is how SIMD operation will happen. This is another thing.
Suppose we wanted to do one any like vector multiplication or some method. We will write the code only in C. Right?
C++.
C++. Then it will be compiled automatically into this form, right?
It will be compiled like microcontroller will write C program. It will be compiled into assembly language. Here also we will write C++. It will get compiled into intrinsic function.
HLS or directly
HLS.
through HLS?
Through HLS. Because when we built and compiled, you saw no HLS.
So
Through
basically we write in CPP.
CPP.
If we want to check what it has done, that time we can see this.
Correct. That I will show you. In a debug window, a disassembly window, we can see like how we see no the disassembly window, we'll see assembly language code, no, like this. Here also disassembly window, we can see this low level code, machine language code, we can see same way, same like our C program that we write. C source code, C program, user program will get converted into lower level language, machine understandable code. Finally you will get ELF. Same pattern here, but here not exactly assembly language, it is some different way. That's what I'm trying to show you now.
That basic optimization and advanced optimization which you have mentioned. So basic optimization means every function will simply translate to one of these instructions. And advanced means it will do by itself to remove some of the.
For example, I want to add always 1 to some code. So what I will do, move hash, I would have written move hash 1 comma R0 or whatever register. Again I will say move hash 1 comma R1, move hash 1 comma R2. So how many, instead of that INC will be used. Every time you are adding 1 only. So this function every time I am adding 5 only. Instead of, if you have written a lengthy, that is inbuilt optimization will happen. If I give optimization, if I mention no optimization will happen. So this one, okay. Then that's what is all about this vector. So these are the vector register file. There are some other functions like incremental function that I'll show you in next this one. Okay. So there are these are all X operands, Z operands, output finally, and it all works at 1 gigahertz. And one more thing is, every time this changes will happen, input to output, it will happen with some clock rate, clock speed only. At every clock cycle, this should happen. So if I am giving inputs to SIMD, how many clock cycles it takes to give me the output? That depends on how I have given B4, 4 lanes, 1 clock cycle. Like that, if you are giving second set of data, another clock cycle. So the number of clock cycle depends on how you are giving. So that is interdependent. Okay. Then this is about all scalar and vector operations with respect to this one. Now I'll show you one more example. After that, we will see one simple demonstration with and without NOC. Okay. Okay. This is one example. Now I want to show you the intrinsic function, how it is getting. So make file, get into the tree, get into the directory where you have created a project. Simply type tree. You will get a list of the flow of how you have created. In that only you can see the make file. You can see how the make file is generated. Okay. Now the programming model we will just see here, one programming model. So I'll just show you the programming model, single kernel. Okay. So how the programming model looks like for single kernel, how the programming model looks for multiple kernel. So this is another lab which will talk about the APIs. This lab is basically filter operation. So this is the sequence that is given 1, 2, 3, 4, 5, 6, 7, 8. Convolution of this sequence is happening. Convolution we all understand, no? H of 1, that formula, DSP related formula only you have to follow. So after convolving this, what will be the output? So you can simply assume one input. This is the input. After convolving, what we'll get as the output? Every memory, you know, inside AI tile engine will have, why it is getting, why I have to divide it as a lanes, V4, V6, because it can only stream a data up to 128 bits wide, not beyond that. And we all know that we are using AI engine for complex functionality, for high level functionality only. So the data is huge, but still you have to divide. That is the understanding. So you cannot simply pass any amount of data as you wish. You have to divide and then float the data. Because streaming, Axile streaming, maximum capacity is 128 bit, whether it is memory based or PL. 128 bit wide means I can pass on only 128 bit of data. So the idea is break the data into lanes, different parts, and then send it. So that's how we are breaking the data into different parts and then forwarding it. Match the data bits. Again, that depends upon the version, all those things also. The portfolio depends on the portfolio. Okay. So here also what I'll do is I will invoke the Vitis. Here I will not show you again a graphical. Okay, I can show. Create application. Next. VCK base 2023 same. I have told you this domain name, XRT. You want to do Linux based application, you have to select this. Okay, and give name. Okay, you want to do via this processor, select AI engine processor. Okay, we are doing for bare metal now. So I'm selecting AI engine. So here I'll select empty application. Finish. If I select empty application, you can try out with all template, example templates here. And then, so if I select empty application, see here, hardware link is created. PL based hardware link is created. So this will be the binary container. Empty it is. Last time when I select, if I add application, here you will get PL and AI. That I will show you now. Okay. So this will be the single kernel, but data and sources are empty. So I'll select this. I can import the sources also. So import sources. I already have an example template here. So you need to have both the data and source. Both should be there always. Okay. Okay. AI kernels, everything will be there. So select this. After importing, you will see data. Reference output.txt, input.txt will be there. So input we have seen, no, what are the inputs? 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 are the inputs. Now source will be AI kernel. If I expand this, you will have weighted sum.cc. This is an example. Okay. So ADF.h is included. Weighted sum. Now can you tell me what kind of data this is happening, whether it is window based or stream based, by seeing the code itself? Whether it is window based or stream based data movement that is happening, or data accessing style, data access mechanism. I told you there are two types. One is window-based data access mechanism. The other one is stream-based data access mechanism. Okay, these are the only two, I think so. Two data-based data access mechanism. In that, by seeing the code itself, we can make out whether it is window-based or stream-based data access mechanism. Now, how can you make out whether it is window-based or stream-based data access mechanism? I showed you last time. So whenever your kernel uses window-based access mechanism, you will have WC written. Okay, WSUM. You can observe here. WSUM, W followed by any variable name. So that is window access mechanism. The another one is stream access mechanism. The difference is when you write the data access mechanism using window-based, no, it is choosing local memory. It is choosing local memory. That is window access mechanism. So kernel is loaded in AI engine whenever input window is filtered and same memory will be chosen. If you select stream-based mechanism, stream interface will be selected. And it can be a local memory or it can be some other memory also. But window-based mechanism means that tile may whichever memory is there, no local memory, only that memory will be selected. That is the difference, data access mechanism. Window-based data access mechanism and tile-based, stream-based data access mechanism. Window-based means you will have an option of selecting local memory. Stream-based mechanism means again AXI will come into a picture.
हाँ भाई, एक वेबिनार છે આર્કિટેક્ચર ને ડિઝાઇન ફ્લો વિથ વર્સલ એઆઈ એન્જિન, તો તમારે જોઈન થવું હોય તો લિંક મોકલો.
કોણ સર?
Talking to someone else. Kindly mute yourself. Okay. So those are the two mechanism. Now how will I write the so this one I told you, no, if it was vector V8 in 32, it had have been incremented by 32. So if it is window based, you will have WSUM. Otherwise, you will have only a variable name. Okay, so that will be the difference. And in the kernel.h, you will have adf.h. This will be auto generated. You will not write this code always, auto generated. Pragma. So it always uses pragma. Pragma is a directive of the compiler. Pragma, hash pragma is directive, compiler directive. User namespace, and every time you will have if definition and all. Just that is for verification that this library is included. Conditional directive, okay, conditionally it has to be included. So all these things I have now included the existing library. So with this I showed you that you need not always choose a template. You can write your own code and include that. Okay, but if you have a data here, it is always better reference output dot text and reference. So you can have a text format of the outputs here. So that is possible, and you have to write a code. Rest all will be created automatically. Then select this. Okay, before getting into this, I have to emulation AI is there. So I will select this, build, and same procedure. Rest all will be a same procedure. I included, no? Something. Optimization and then I included, no, those two live files. Yeah, it is included here. Okay, build. Okay, one more thing, what happened, why it is giving error, I understand. I will just remove. Can anyone tell what is the error? All these are. So while including now, what was the problem is, I am doing this. Import sources, browse. This has to be included. Only thing was this into folder mein we have source. This is not getting into this source. Already you have the expansion, so this has to be deleted. That's why it is getting into source, again source. So one more tree subfolder it is getting created. That was the reason. Now I will just build this again, because earlier I'll have to create new and then it works fine. Okay. I'll recreate once again. We'll just check once. So we have selected AI engine. Okay. Then next is we'll have this program followed by hardware link platform will be created. Data and source is selected. Okay. It should get included. And this is the program.
I think this time you selected the parent folder of the files instead of the source folder.
Is it? Okay, no, this time it is hardware. No, maybe that is the reason. Wait, once we'll check. I will put into emulation AI. No. We'll just redo this after lunch again. Huh? So the observations are only with respect to this changes in the code. Rest all will be the flow will be same, build and run as AI engine emulator. Again, you will get a graphical view. So this lab, the intention was just to show you again the flow of the AI engine tool flow. Okay, nothing else. Now, if I want to add multiple kernel, then also it is possible. So you need to have one more .cc file. So one more .cc I will just add here. Okay, keep it as it is. After lunch we can just simulate and check. Okay. So if I want to add multiple file, so what I'll do is I will go to source. I have already a code. I will just import the source. So you will have documents. So any one design I will take. So again, I can add this source and data. So again, you have support. In parent, I added. I removed this backslash also last time. Maybe that is the reason. Okay, finish. Overwrite. Just one. Maybe that was the reason. We'll just check. So you'll have multiple kernels that will be included here. So you'll have two .cc files that will be there. And when you observe on the graph, you'll have node 1 followed by node 2. Node 1 will be name of weighted sum, a chain. Second, the network, you will have a chain of average DIB. So the node 1 output will get into node 2 and then finally. Now, if you make this as a top module, then this will be node 1 and that will be node 2. So you'll have a chain of a data, how it has to be passed. So you can have multiple kernel based code also. This will make it work. Okay, just give me till afternoon will. Then, so you can also iterate a data over a buffer. Intentionally, you want to add a buffer, that is also possible. In the code itself, you have to modify, add a buffers, and then take it through the thing. Else also, mandatorily, some buffers will be created. Okay. So some constructors, depending on the name that you have chosen, that constructor will be created. Okay. As I mentioned already, PLIO and or GLIO will be created. GLIO is related to memory. PLIO will be related to the other program, other aspects, other entities like peripherals or anything. Okay. So as I have already mentioned, these will be the methods of loading the graph: init, run, and end method. These are the three methods. So completion of the execution and termination will happen. Okay. So this is about your AI engine emulator, how it works. So afternoon session, we will see. We'll stop now. We'll come back at 1:30. 1:30, yeah. 1:40. 1:45. We'll join back at 1:45 and we will see some NOC and without NOC based some simple hardware design I will show. And I will show you the hardware design with respect to AI. Okay, these three things I will be showing in the second half session. Okay, we'll join back at 1:45. Okay, thank you.